In this question, we have two signals, x and y. Each of them is a pure sinusoid, and we multiply them together to form a new signal, z of t. And the question is, what's the highest frequency component in z of t? Okay, so let me just make that even clearer. So if the question was a simple addition, if we were simply adding x and y, then we would simply look at the two frequencies, 6 pi and 2 pi, and take the higher of the two. So in this case, the answer would be 6 pi radians per second, or it would be 6 pi over 2 pi equals 3 hertz. So that would be the answer if we were adding the two signals. But as it happens, we're not adding them, we're multiplying. So let's now think about what happens when you multiply two sine waves. So remember that sine A multiplied by sine B will give you something like cosine of the difference minus cosine of the sum divided by 2. Now, that doesn't really matter whether it's a minus or a plus, and the 2 there isn't really important. What really matters to us is this term here, because they're looking for the highest term. So for the highest term, it's obviously going to be the sum of A and B. So what we have is z of t equals 3 times 5 is 15 sine 2 pi t times sine 6 pi t. So if that's our A and that's our B, then the highest frequency will be equal to the sum. So A plus B. So it'll be 2 pi t, or 2 pi, plus 6 pi equals 8 pi. But that's going to be in radians per second. Now, if we wanted the frequency in hertz, it would be 8 pi divided by 2 pi to convert it, and that would give you 4 hertz. So that's your answer. So whenever you have signals that are multiplied, whenever you have a product of sine waves, you're always looking at the sum of the frequencies.